Today I'll be going over the concept of linked lists, which I guess you can think of it as a data structure, although it's not really stored. Um, it's not, I guess, stored in a contiguous memory location. Rather, it's connected by pointers, which I'll explain right now. So, how do they work is if you have, let's say you have um, you can think of it as a node with data in it. So let's say you have, I'll just label it A. And you have this node right here. So what linked lists have is, one, they have the data, so like the value or the payload, and two, they have the link, which is, I guess, a reference or pointer to the next node in the sequence. So for this node right here, we can think of it as it has another value. Actually, we have this another node called B, and A points to B. So, or not A points to B, but let's just call this 1 and 2. So this value, I guess this node 1, which contains the data A and also a pointer to 2, and 2 has I guess you can think of it, the value B or whatever's in B, and then it goes on as long as you need it to, I guess. And yeah, the whole point is that it has data and then a reference to the next node in the sequence, and in this way you can kind of keep track of it as kind of connected like a tree or something like that. And you can actually have different types of linked lists where we see this one, it's just pointing from one node to the next, but we could also somehow have it point from, I guess if you call it this the parent node and this the child node, you can not only point from the parent to the child, but also the other way around. So in this way, let's say we start at node 1, we can go to node 2, and then node 3, and then if we ever have to go back to node 1, we have the pointers to the previous node. And another type of linked list is a circular linked list, where if we just say we delete, if we have these nodes right here, it doesn't matter what's in here, but we can have this final node point to the initial or original node. And this way we kind of have like a circle that's all connected. And yeah, so the key operations for linked lists are you can insert, which is adding a new node, and this can be anywhere. All you have to do, or I can explain that later. You can delete, you can traverse, you can search. So I guess the good part about a linked list is that it's dynamic in size, so it can grow and shrink depending on how you want it. So let's say we wanted to insert D here, or sorry, node 4 with the value D in between B and C. Well, you don't have to really do anything other than change, choose a different color. You now change the pointer of B to point to node 4, or sorry, node 2 to point to node 4, and then point node 4 to node 3. And then if you have like it going back, you can also fix that too, change that up too. And yeah, in this way you can essentially manipulate the pointers of the nodes so that you can insert, or if you want to delete, you can erase this and then make it point this way. So yeah, you can play around with that and manipulate the pointers of each node to add or delete. And you can also, I guess, traverse by starting at a node and then following wherever it points to see what node comes next. And yeah, searching, you can also loop through all the nodes to find which one. Yeah, and so in this way, rather than having a set amount of storage, so like an array, you have to define the storage, or a memory linked list, you can simply just create nodes whenever needed, and in this way, there's no memory wastage. I guess the disadvantages that come with linked lists are that you can't really access nodes. You can't do random access because there's no direct indexing. So let's say if I wanted to go to 3, but I didn't know, or let's say I wanted to find what the value of C, but I didn't know what the index, or sorry, the node was, then I'd essentially have to search through the entire thing. And that comes with, even if I knew which node it was, I'd still have to go through all the pointers. I'd start at 1 and then go to 2 and then I'd go to 3. So advantages are that dynamic size and no memory wastage, whereas the disadvantages are that no indexing, no random access, or it's hard to do random access. And additionally, you do need extra memory for the pointers. Because for each node, you not only need the actual value, but you not only need the actual value, but you need the pointer wherever that's pointing to. And yeah, so that's basically the whole concept of linked lists, which is very, I guess, it's like a fundamental data structure. And yeah, thank you for watching.